Dr. Romano. I'm professor of organic chemistry here at Romano Scientific and the creator of the DAT Destroyer book. I'm here today with Professor Blois, who's going to do some word problems with us. And this particular set of questions are going to be called combined work problems. Is that correct?
Combined work,
So
yes.
Combined work problems is a very in-demand topic. Kids are always emailing me for questions on how we go about setting up these questions on word problems for the DAT and the OAT exam. So Professor, if you can show us what you got.
Okay, today I'm going to do two combined work problems. The first, a very standard one, a textbook combined work problem. But then the second one, I'm going to introduce a little bit of twists and variations to prepare you for other possibilities that how the question may be asked. Okay, let's read the first question. Working on their own, Larry takes 2 hours to mow a lawn. Mike takes 5 hours, and Nora takes half an hour. How long will it take if they all work together? So the standard way of doing this is to write this equation. 1 over Larry's time plus 1 over Mike's time plus 1 over Nora's time equals 1 over the total time. What we're really doing here is adding rates. And you may know that in word problems, the one thing you try to avoid most of the time is adding rates. The reason why we get away with it this time is because everyone is contributing to accomplishing the same task. So each of their rates is contributing to the overall rate at which the task is being performed. Okay, so let's just carry this out. 1 over Larry's time, well, it takes Larry 2 hours, 1 over 2. It takes Mike 5 hours, 1 over 5. And it takes Nora a half an hour, 1 over 1/2. And that is going to lead to 1 over the total time. Now, we anticipate that the total time is going to be less than half an hour. Nora does the whole job in a half an hour, right? So we expect the answer to be less than a half an hour. All right, so all we have to do is solve this problem. 1 over 1/2, let's get this detail out of the way. You should know that 1 over 1/2 is equal to 2. Okay, let's rewrite this, plus 1 over 1/2. And you can prove that just by multiplying numerator and denominator by 2. This becomes 2 over 1. And that equals 1 over t. How do you solve a problem like this? How do you solve a problem with fractions? Well, if you have a problem with fractions, what you want to do is just multiply both sides of the equation by the LCD. That will completely clean away all fractions. So what's the LCD here? Let's write what the LCD is. The three denominators are 2, 5, and t. So therefore the LCD is 10t. So what I want to do is multiply each term on each side of the equation by 10t. 10t here, 10t here, 10t here, and 10t here. What do we get? 2 divides into 10t, we get 5t. 5 divides into 10t twice, we get 2t. 2 times 10t is 20t, so that's 20t. And on the right side of the equation, the t's cancel out, and we're just left with 10. So let's add this up. 5t plus 2t is 7t, plus 20 is 27t. We get 27t is equal to 10, and therefore t is equal to 10/27ths of an hour. Okay, so there we are, and 10/27ths is less than 1/2. 1/2 would be 10/20ths, so 10/27ths is less than a half an hour as we anticipated, so that's our solution. Okay, now let's go to the variation. I put a little twist in here, and you'll see how I change things around to make it a little bit more interesting. Pipe A can fill 1/3 of a tank in half an hour. Notice the incorporation of fractions. Pipe B can fill 1/3 of a tank in 1 hour, while pipe C can empty 1/4 of a tank in an hour and a half. How long will it take to fill an empty tank if they all work together? Okay, so what we have here, well, how we're going to construct this is along the same lines as we did in the previous problem. The only thing is we're going to put the fraction of the tank that is filled in the numerator and the time it takes to fill that in the denominator. So pipe A can fill 1/3 of a tank in half an hour. We have the fraction 1/3 over 1/2. That's its rate. Okay, pipe B can fill 1/3 of a tank in 1 hour. So we have 1/3 of a tank in 1 hour, right? time over the fraction of the tank over time. And finally, pipe C can empty. Now, pipe C is working against pipe A and pipe B. Therefore, I'm going to put a negative sign here. It's emptying the tank. So it's 1/4 of a tank, 1/4 of a tank in an hour and a half. Well, what's an hour and a half? It's 1.5 hours. So that's the fraction 3/2. And when we add all these together, we're going to get the same as before, the reciprocal of the total time that it's going to take for all three tanks, all three pipes to work together. All right, so now we come to the point of simplifying this. How do we simplify this expression? All right, let's go one by one. We have the first fraction. Let's multiply it by 3/3, and we'll get 1/3 1/3 is going to give us 2/3. So let me make some space up here, and we'll continue this problem in this space up here. So 1/3 is going to give us the fraction 2/3. All right, what about the second fraction, 1/3/1? Well, 1/3/1 is simply 1/3. The third fraction is 1/4/3/2. Well, let's multiply numerator and denominator by 4. We will get minus, in the numerator, 4 times 1/4 is 1. In the denominator, 3/2 of 4. 2 goes into 4 twice. 3 times 2 is 6. Okay, so it's 2/3 plus 1/3 minus 1/6 equals 1 over the total time. And now, look how easy the expression is. Now it's very easy to solve. I have an equation with fractions. I can see right away that the LCD is equal to what? What are the denominators here? 3, 3, 6, and t. Therefore, the LCD is 6t. I'm going to multiply each of these fractions by 6t, turn the crank. So 6t times this fraction, 6t times this fraction, 6t times this fraction, 6t times that fraction, and here we go. 3 goes into 6 twice, 2 times 2 is 4, 4t. 3 goes into 6 twice, that's plus 2t. 6 goes into 6 once, that's minus t, and here the t's cancel out, and that equals 6. So 4 plus 2 is 6, minus 1 is 5, so it's 5t equals 6. So t is equal to 6/5 or 1 1/5 hours. What's a fifth of an hour? 12 minutes. So this is equal to 1 hour, 12 minutes, and there's the solution to that equation.
Okay, Professor Blois, thank you very much. I hope you guys enjoyed that. I can't stress enough how important these tapes are for the DAT and the OAT exam. I know there's some sites out there that have dental students solving math problems. I don't really think you can compare a dental student to Professor Blois. I'm not even going to ask how many years you've been teaching mathematics. Let's just say a little bit more than a dental student, and I can attest, this guy was my math teacher. He would smash the best minds on planet Earth in math. So I think you're in good hands. If you can learn from all these tapes, you will be able to ace this math section. And Professor Blois has written a ton of questions in our Math Destroyer, so check that book out, and you can see all the math questions that he's done. All right, guys, good luck. Bye-bye.